Have you ever wondered how magnificent, ancient structures like the Colosseum in Rome or the towering pagodas of Japan have survived centuries of violent earthquakes while modern buildings sometimes crumble in seconds? It seems almost impossible, right? But the truth is, ancient engineers possessed a remarkable understanding of seismic forces, and they embedded ingenious earthquake-proofing secrets into their architecture. Today, we're going to journey back in time and uncover these incredible feats of engineering that have allowed these wonders to defy nature as fury. So, how did they do it? It wasn't magic. It was brilliant. Practical science. Let's start in ancient Rome. The Romans were masters of concrete, but their concrete wasn't like ours. They used a special mix with volcanic ash called pozzolana. This Roman concrete was not only incredibly durable, but it was also surprisingly flexible. When an earthquake struck, the microscopic structure of the concrete could shift and reorganize, absorbing the seismic energy instead of shattering. It could even self-heal cracks over time. This is a huge reason why structures like the Pantheon and the Colosseum are still standing tall after 2,000 years of seismic activity in a very active region. They didn't just build strong. They built smart. Now, let's travel east to Japan, a country that experiences over 1,000 earthquakes every year. How did their traditional wooden pagodas, some reaching over 180 feet high, endure this constant shaking? The secret lies in a central pillar called a shinbashira. This massive wooden column runs up the core of the pagoda. But here's the clever part. It isn't actually connected to any of the floors. It's essentially a separate, freestanding element within the structure. Imagine the pagoda as a stack of loosely fitted boxers. When an earthquake hits, each level can sway independently, moving in a snake-like motion. This flexibility dissipates the earthquake's energy. The shinbashira acts as a stabilizing counterweight. Like a pendulum, as the pagoda sways one way, the central pillar sways the other, balancing the structure and preventing it from tearing itself apart. This design is so effective that it has been studied and adapted by modern engineers for building earthquake-resistant skyscrapers. It's a perfect example of learning from the wisdom of the past. But it's not just about the internal structure. The foundations were just as important. Take the ancient Incas in Peru, for example. They lived in the Andes, one of the most seismically active mountain ranges in the world. Their masonry is legendary. If you've ever seen pictures of Machu Picchu, you'll notice the massive stones are cut so precisely that you couldn't even fit a knife blade between them. This wasn't just for looks. The Incas used a technique called ashlar masonry. They shaped these enormous granite blocks with multiple interlocking faces, like a complex 3D puzzle. The stones weren't held together by more. Instead, their precise fit and immense weight did the job. During an earthquake, these stones could literally dance. They would move and jiggle, accommodating the grounds, shaking, and then settle right back into their original positions once the tremor stopped. The slight inward incline of their walls also lowered the center of gravity, adding another layer of stability. This is why so many Inca walls have remained perfectly intact for over 500 years, withstanding countless quakes. Let's head back to Europe, specifically to ancient Greece. The Greeks were also no strangers to earthquakes. The Parthenon, perched atop the Acropolis in Athens, has survived for nearly 2,500 years. How? While it appears to be a rigid structure of marble, it's full of subtle engineering tricks. The columns are not single, solid pieces. They're made of stacked drums, connected by wooden dowels and a central pin. This segmentation allowed for a tiny amount of movement during a quake, preventing the columns from snapping under stress. Furthermore, the entire foundation wasn't built on flat bedrock. The Greeks placed the temple on layers of different materials, which could have helped dampen seismic waves before they even reached the main structure. It's a form of what we now call base isolation, a cutting-edge technique used today where a building is essentially decoupled from the ground to protect it from shaking. The ancient Greeks might have stumbled upon this principle through observation and trial and error, centuries before modern seismology. Across the world in ancient Persia, now Iran, engineers also developed innovative solutions. The city of Bam, with its magnificent citadel, stood for over 2 millennia before a devastating earthquake in 2003. but its longevity was thanks to clever design. The Persians used adobe, or mud brick, but they reinforced it with straw and palm fronds. This acted like modern rebar, adding tensile strength to the brittle brick. They also build with domes and vaults. The curved shape of a dome is inherently strong and distributes weight and stress evenly. During an earthquake, the forces flow around the curve rather than concentrating on weak points, making them far more resilient than flat roofs. It's fascinating to see how different cultures, separated by thousands of miles and thousands of years, arrived at similar principles. Whether it was the flexible concrete of Rome, the swaying pagodas of Japan, the dancing stones of the Incas, or the segmented columns of Greece, the core idea was the same. Don't fight the earthquake, flow with it. Instead of creating perfectly rigid structures that would snap under pressure, they built in flexibility and mechanisms to dissipate energy. These ancient engineers were the original seismic experts. They didn't have computers or advanced sensors. Their knowledge was built on generations of observation, intuition, and heartbreakingly, learning. Every collapsed building was a lesson in what not to do, and every structure that survived was a blueprint for the future. They studied the land, understood their materials intimately, and respected the awesome power of the earth. Today, as we build taller and more complex structures, we are looking back to these ancient masters for inspiration. Modern seismic engineering concepts like base isolation, damping systems, and flexible joints are really just high-tech versions of what the Japanese and Romans were doing centuries ago. They proved that sometimes the most enduring solutions are the ones that have stood the test of time. Their legacy is not just carved in stone and wood, but in the life-saving knowledge they passed down through the ages. So, the next time you see a picture of an ancient ruin, don't just see it as a relic of the past. See it as a masterpiece of survival, a testament to human ingenuity in the face of one of nature's most destructive forces. It as a powerful reminder that we still have so much to learn from those who came before us. Thank you so much for joining me on this journey through architectural history. If you found this as fascinating as I did, please give this video a thumbs up and hit that subscribe button for more explorations into the secrets of the ancient world. Let me know in the comments which ancient engineering feat you find most impressive. Until next time, stay curious.